Hello, everyone, and welcome to today's SANS webcast. ICS Cyber Resilience, Active Defense and Safety, Part 1. My name is Carol Auth of SANS, and I will be moderating today's webcast. Today's featured speakers are Dean Parsons and Stephen Mathiser, both are SANS instructors. If during the webcast you have any questions for our presenters, please enter them into the questions window at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to our presenters.
Excellent. Thank you so much, Carol. Hi, everybody. Thanks for joining us for today. This is a actual first part of a webcast series we're doing on ICS Active Defense and Safety as well. So before we get in, what I'm going to do is just quickly do an introduction. Myself and my partner in crime for today, I'm going to pass this over to Stephen for that introduction.
Morning. Thanks, Dean. Just a quick intro. I am a certified SANS instructor for the ICS 410 class, ICS SCADA Security Essentials. I think I'm teaching that almost monthly for the next several months, so you can check that out. My background has been in working for primarily a large oil and gas company for a long time in various security roles, including all of the ICS security architecture and operations from a cybersecurity perspective. Since then, I've joined another company where I'm the principal, and I'm supporting security assessment, pen test, vulnerability management, and so on for our industrial customers.
Excellent. All right. Thank you very much, Stephen. My name is Dean Parsons. I'm also a certified instructor. I mainly teach the ICS 515 class, which is the Active Defense and Incident Response for Industrial Control, SCADA, and OT environments. Long story short, 20 years experience in IT and industrial control systems, the last 10 years specifically in the oil and gas sector, but also the electric sector as well for electric generation, transmission, distribution, and also assessments in industrial control systems at a technical and high level across multiple sectors in the ICS area as well. And one last note, co-author of the new upcoming in development ICS 418 class, which is a specific class for managers for industrial control systems, and that is 418 ICS Security Essentials for managers. A little bit more on that later. Okay, we're going to jump right in and kind of lay out the land for today. Again, this is the first part of a webcast series on industrial control systems, and over this series we'll be covering these 7 areas here. We're going to start off today with part 1, really looking at the foundational components of industrial control systems, what makes up the ICS, how attackers target some of those assets in the ICS. We'll obviously talk about things like architecture, which is a big component for today's discussion. And from that, we'll talk about things like ransomware impacting critical infrastructure that we've seen in recent events across the community. We'll talk about different threat vectors as well. And as we go throughout these sessions over the next 1 to 2 months or so, we'll talk about advanced persistent threats targeting industrial control systems, how we can detect those maneuvers that they have in their tactics, techniques, and eventually get to something like threat intelligence and using that for threat hunting in the ICS environment. Every webcast we will have takeaways, so we'll have top 3 takeaways each section we kind of go through, each webcast we go through, and at the end of each webcast for the series we do have free ICS resources that you can take and leverage from a practical perspective right after the actual webcast as well. But for today only, we will be talking about the differences at a very brief level on the differences in ICS security and IT security, and that'll pivot us into discussions around ransomware on IT and ICS and dependencies there. We'll talk about recent events, of course, in the last number of months, weeks, and also this past year and a little bit before that as well. We'll jump into that component aspect of ICS, really talk about the Purdue and the ICS 410 reference architecture for network segmentation, which is critical and affordable for practical defense. We'll close out today with those 3 practical minimum things we should be taking away from this session together today. And of course, as usual, we'll go into a Q&A section at the end as well. So if you have questions as we go along, please drop those into the chat panel. We'll collect those. We'll address those at the end of the discussion today. All right. So without further ado, just a brief look at the differences at a high level between security in IT environments and also in the ICS environments as well. Now, most of us do know the differences at a high level are really in IT. We're moving and enabling security for data. So securing data in transit, but data at rest as well. In the industrial control space, we're really enabling safety, enabling security, and really physics. So the idea is that we have, physical components that we interact with that can change our physical environment. And so the environments we're talking about are environments like oil and gas refineries, for example, cookie factories, beer manufacturing facilities, manufacturing and logistics for things like vaccines. These kinds of industrial system and plants is really kind of what we're going to be focusing on as we go through. But of course, there is an IT element there that we're going to adapt and adjust that for the industrial control system space. So one of the main things between securing data and securing physics and enabling safety is the impacts and the mission between IT and OT and the differences there. So in general, if we have a bad day or an incident in IT, we have applications that are unavailable, email, data unavailable, data breaches, brand tarnish as well, which is never a good thing. In the ICS space, we have different losses and different incidents. So in ICS, we're talking about loss of control of physical processes, manipulation of those processes by adversaries targeting the industrial control space. Potentially, we have things like human safety, loss of life, and environmental impacts as well. And that's that physical representation of a cyber threat in the real world. In general, if we were to quickly summarize the differences between IT security and the ICS security space, moving data and securing data versus physics, we're really talking about these specific areas here. Now, safety is also highlighted here because that's the main concern in industrial control system space, whereas in an IT, the main mission is confidentiality of data, for example, integrity and availability. Safety is the utmost in ICS, along with integrity of commands for controlling those physical devices, as well as availability being less than safety as an example. So safety is number one. If we look at the skill sets required for ICS security, of course, cybersecurity is a big part of that. Cyber defense is a part of that, but there's also skills that require a nuanced discussion to adapt and use security tools and technologies out there in a way that is more suited for the safety and reliability of operations in ICS. And one example of that is security incident response. So if we take incident response tools and incident response capabilities and the normal steps, so we have 5-6 steps of incident response, and put that inside the industrial control system, we're actually going to break things. So it's not the appropriate thing to do to take IT controls and processes and put them right inside the ICS. Some other areas beyond the controls, the cybersecurity controls, there's the support as well, and also system design. Now later Stephen will talk about the architecture and the design of an architecture and a network inside the ICS. And so some of these elements here will become evident as we go through. Now, of course, we can't talk about industrial control systems and security and IT security and OT security without talking a little bit, just for a slide or two, on convergence. So I'm here to tell you that we've actually converged the technology of ICS and IT 20 years ago, where we've actually been leveraging IT or traditional operating systems in general and some traditional protocols in the higher levels of the ICS environments, higher levels of the Purdue 20 years ago. So things like XP, as you see on your screen here, is actually still somewhat common in the industrial control system space. So we do have some IT devices in the industrial control space supporting those physical changes in the environment as well. So really the conversation we see today in the industry is not so much, are we converged from a technology perspective? It's really, how do we converge the teams? How do we converge the people? And how do we get the skills from a cybersecurity perspective and use that appropriately in the industrial control space to support the safety and reliability of industrial control system safety and of course operations. So on your screen, you're seeing XP there. Of course, there's Windows 7, Windows 10, and Linux in the ICS space as well. But there's also other assets, such as these that you see on your screen, which we'll talk about later in this webcast. And those engineering assets, I really want to put forth that there's more engineering assets in there than we have IT devices. And speaking of that, we're really going to focus just one more slide on convergence and talk about what we typically see in the IT space: common operating systems, off-the-shelf operating systems, traditional protocols. So Windows environments, Linux environments, which are probably a lot more patched and patchable in the IT space than we have in the industrial control space. Patching we'll talk about in a later episode of this webcast series. But of course, we have things like SSH, HTTPS. We have email protocol being utilized in the enterprise and IT environment as well, SMB as we mentioned. But once we go down into the industrial control system space, of course, we have some of that a little bit at the top level, I'll call it, of the industrial control space. So SSH can be found there, Telnet can be found there as well, a little less secure of a control protocol, but also SMB and HTTP as an example. And then from there, we now go deeper into the industrial control space and see specific proprietary in some cases, but some open industrial protocols like OPC, ICCP, also Modbus TCP. We see various other ones as well. When you get down to the field, we're going to talk about things like Profinet and Profibus, and also embedded HMIs, human machine interfaces, and engineering devices such as PLCs, RTUs, and of course, actuators, the actual physical components in industrial control systems that we control to change the physical world. So as we see here in this red section, we're really going to at the high level start off with some familiar operating systems, some familiar protocols, and then drastically see different ones as we go further and further down into the stack in the industrial control system space. See some questions coming in there. Great stuff. Keep putting those in there. We'll address those in just a little bit. So what events have we seen over the last number of weeks, months, and years? So of course, we're going to talk about what we've seen in 2021 so far. We're just over halfway through 2021, so we'll see what else is going to come this year. The good news about some of the takeaways from this session today is that some of the things we're going to take away is you can apply that in your organization at fairly low cost. It's affordable defense to protect against some of these events we've seen here, and build upon that as we go through this webcast as well. So I don't want to go too far back in history, but I just want to say with this slide how we've seen attacks increase in sophistication, but also the interest of adversaries as well, and their skills targeting the industrial control space. This is going to be extremely relevant when Stephen talks about architecture and why we've really taken that look at architecture and the nuanced discussions for security for remote access into some of these plants and environments as well. So way back in the 1990s up to 2000, where we're seeing, rarely do we see industrial control system spaces connected to the internet. A lot more isolation back then, not a lot of dependence or any at all on IT environments, but we're seeing that change over time. Now, what I want to point out here in the 2000s to 2010, of course, we see the predominant IT viruses starting to surface and focus on the business network. We see some start at that point in the engineering space, the utilization of IT traditional systems in the industrial control space. And that's that start of the ITOT convergence for technology. So at that point, limited targeted attacks for industrial control systems. And it's important to know at this point, limited sophistication or even knowledge of how to attack these environments early stages. I'll try my best not to say Stuxnet here, but we're all thinking it. When we go through to 2010 to up to today, we're really now seeing things the last 10, 11, 12 years, specifically targeted industrial control system attacks. So not attacks on a Windows device as such. We're seeing industrial control attacks on environments, or sorry, assets, which are engineering assets. Stephen will talk to PLCs later, and we'll talk about the human machine interfaces. And those are the exact critical assets in the ICS environment that are being targeted, and we're seeing successful targeting and actual impacts from the adversaries in these environments. One other point here as well, the impacts we're seeing here is now destruction of physical assets and potential for loss of life. We'll cover Trisys quickly in a moment and really bring out something hopefully you haven't seen from Trisys before. And of course, we're now seeing ransomware impacting the industrial control system space as well. So as we are all reading the news and seeing what's coming out on a regular basis, almost weekly now, some kind of targeted attack or even intrusion impacting industrial control system space, we see anything from Ukraine way back 6 years ago or so, and then 5 years ago, 2015, 2016, but also things like the Colonial Pipeline attack, which most of us heard of at this point. Now, that is an interesting one where we're really going to talk about things like architecture and does the IT environment have some kind of application that the ICS relies on to get access to for that ICS space. We'll talk a little bit about some of the other events we'll see as well, so such as the, well, Colonial for sure, but also things like the water plant attacks in Oldsmar as well, and one other one, which was the Honda ransomware attack and intrusion and impact on production at that facility as well. So let's jump in through there. A couple other questions coming in, I see, which is great. So keep piling those in there as we go through. Now, just to briefly talk about the city of Oldsmar, what did we see in the city of Oldsmar? Well, there was a water treatment facility there, and in February 2021, there was an intrusion and an adversary directly got attached to or access to the human-machine interface. That, of course, is the ability to change that physical process, modify the physical process, and in this case, change some output for the water treatment facility. Now, in here on your screen, you're going to see the human-machine interface in this case, which is on your right side. You'll see a red box around that as well. These are the actual commands and interface to change that physical process. And in this case here, the adversary got access to this interface and changed the level of a chemical inside the water treatment facility. Thus, if it was unnoticed and the safety systems did not see this change, or an operator did not see this change, could have been catastrophic for human consumption from this water when it was treated for human drinking water, etc. So we see that the attacker tried to raise and did actually raise the levels of sodium hydroxide to a dangerous level, so a factor more than 100. And in this case here, that was noticed by an ICS operator, somebody typically using the human-machine interface on a regular basis. So there are different safety systems inside the control system space that are passive and also active that help detect these types or other types of safety concerns, but we must not always try to rely on those all the time. So it's great here to see somebody looking at the system and then changing the system back to its normal state. Suffice it to say, we do see an attacker at this point here, which is unknown still today, using an insecure remote access from the internet directly to an interface in the facility, changing the chemical makeup of this system for drinking water. So again, the targeted asset here was the HMI, the adversary is unknown, and remote access was the typically, in this case, the actual vector to get access there to the control system. So we pivot on just to briefly look at the Colonial Pipeline attack, which happened earlier this year as well in May. We see now the targeting is in the oil and gas area. We see this is actually the fuel distribution pipeline as well, where the Colonial Pipeline has upwards near 5,500 miles of pipeline producing and transmitting, if you will, or transporting 100 million gallons of fuel per day. Now, in this case here, ransomware was part of the impact on the IT environment where the adversary targeted the malware, the ransomware, the dark side ransomware. And in this particular case, there was no evidence of ransomware on the industrial control system space. This raises a lot of questions. In this case here, we do have intelligence indicating that for safety reasons, the OT or ICS environment was shut down, and there was an impact to production because it was safely shut down to try to protect the control system from any type of ransomware or other types of attacks, given the breach and compromise on the IT network. So it raises the question, how much do the ICS or OT environment rely on the IT space for applications, support, etc.? In this particular case, the adversary was known, at least the adversary group that took credit for it was the dark side adversary group that created the dark side ransomware. In this case here, we do see leaked credentials from that company on the dark web for sale, which enabled the adversary to get access to the IT environment to get that initial foothold. Now, what's important here, in a few slides, we'll talk about the trends we're seeing through these attacks and other attacks as well that go well beyond the scope of this session, but we've kind of put a lot of the attack trends in a slide that's coming up. In this case here, we do see that foothold in IT, and one of the trends, you've guessed it, is pivot from IT into the industrial control system space. We also see again here the IT network only. Can you isolate your IT network from your ICS? in an environment. And again, the question is, how much do we rely on the IT enterprise business network to do industrial control system processing to maintain safety and keep the industrial engineering process up and running? If we take a quick look as well, now still in the oil and gas sector, we are seeing the Trisys Trisys malware specifically designed to target engineering assets, specifically the safety instrumented systems in an oil and gas facility. But these also active safety systems, or SIS, can be in other types of environments as well, so not only in oil and gas. So this is a prime example of a targeted attack using and abusing legitimate protocols and legitimate devices inside of the industrial control system space. So nothing to do with ransomware, but a specifically targeted attack for the industrial control space. Now, the malware in this particular case, the Trisys malware, was used, and it actually manipulated part of the specific engineering asset, which is the Triconix controller in this case. And in this case, we are fortunate that the safety instrumented system did trip off and shut down the actual oil and gas facility in a safe manner. We're fortunate in this case because that was not the intention of the adversary based on the analysis of the Trisys code here. So what are we saying from a Trisys perspective? We do know the adversary was the Xenotime adversary group, and they actually disguised their malware as trilog.exe to manipulate the safety control system. One of the other interesting things about this, which will come up in a few moments on trends for ICS attacks, is really, again, that pivot from an IT environment to the OT environment, and in this particular case, changing and compromising the ICS engineering workstation, specifically in the levels of the Purdue model for the ICS environment. So that attack trend we have been seeing time and time again. So if we summarize these general attacks into what trends we're seeing, these are the characteristics we're seeing the adversary take. Generally, we see the adversary in some cases taking a foothold, trying to get access into the IT environment. That can be used for several things, to create havoc with ransomware on the IT environment, but we also see the adversary learning from the IT environment about what could be on the ICS environment as well. Of course, we've seen ransomware on IT. Colonial is a perfect example of that. We see also stealing of credentials from the IT environment with these different tools like Mimikatz and other custom tools have been developed to grab those credentials from IT. And we've seen the adversary by tracking them to try to pivot into the industrial control system space with those same credentials. So in this case here, I want to bring up the point there, if you do not have a separate Active Directory on IT that is separate and not trusted with the ICS Active Directory infrastructure, then there is a potential risk there, because we are seeing this tactic and technique used on a fairly regular basis. So cache credentials are a way to enable the adversary to pivot from IT into ICS here. Time and time again, we've seen it with Oldsmar, also way back with the Ukraine attack as well. We see the adversary gravitating towards the human machine interface. So getting access somehow, maybe with remote access, it's unsecure remote access to the human machine interface and directly interacting with it, not even using malware to cause inputs and malicious activity and changes in the physical world. So one of the questions raised here is, what kind of remote access do you have in your environment today? Is it secured? Is it multi-factor authentication as an example? And of course, using tools like Shodan or some other tools to do an open source intelligence gathering in your environment from the outside's perspective, the attacker's perspective, is always a good idea on a fairly regular basis. Now, again, as we pull through, we're seeing native attacks on ICS as well. So specific protocol abuse, application abuse as well, using the HMI, but also the engineering workstation as well, using legitimate assets, using legitimate applications in the ICS against the ICS. This is obviously called living off the land, which you've probably heard of. And the last here I want to speak of is really we're seeing the threats traverse networks. And in some case, the networks are not near as segmented as they could be. One case study here we'll briefly take a look at is the Honda ransomware attack. So in this particular case, threat intelligence indicates we've seen the adversary move from the IT environment and affect other parts of the network as well, which brings up the point about segmentation. So really, when we see adversaries traverse networks, are we really doing the best we can with architecture and design, network-specific segmentation? I get a lot of questions when I do assessments and provide that report back to say, hey, here are some of the things we can do. And an affordable thing you can do is do network segmentation. It does require change control, all of those things, but it does enable you to quickly make changes in a controlled manner that you don't necessarily have to have additional hardware for. So I always go back to the foundation of ICS security. One of the things you can do is architecture. So with that, I will gonna pass it over to Stephen, and he's gonna talk about the ICS components we typically see in environments. Let's recall the IT and security and ICS security differences as we go through the next couple slides with him. And he's gonna brief over the ICS architecture as well for best practice. So I will pass it over to Stephen, and keep up those questions in the comments section there, guys.
Awesome, thanks, Dean. When we when we talk about protecting our ICS networks, as Dean mentioned, we have the only place we can start, or the best place we can start, is at the architecture level. We have a lot of legacy equipment or older equipment, a lot of different equipment varied from different vendors of different ages, of different capabilities. So the best place we can start is by architecting a network that will allow us to put, so let's call them external controls or external protection in place, because we have such a variety of different things. In ICS, of course, we have some of the systems you would, or operating systems you would typically expect. There are Windows systems. There's quite a few Windows systems. Those might be our servers controlling the environment, our human machine interfaces, as Dean talked about, the engineering workstations, a variety of databases, including historians that keep track of what's going on in our ICS networks. And typically we think of those as our supervisory systems. They help us manage everything else that's going on. But as Dean mentioned, there are a ton of other devices out there. And I wouldn't even hazard a guess how many controllers or sensors or actuators we have for every server that we have managing them. But there are far more of these various end devices that we are managing in an ICS network. And this, we just see here some of the examples. We have motors, we have burners, we have drives, we have valves, we have, actuators, anything that we can turn on or off or tune. And of course, we have sensors of various sorts that help us determine what actions we need to take. And very few of those systems are what we would call traditional IT systems, and they're from various vendors in using different protocols, different technologies, different operating systems. And the question then becomes, what can we do to protect those? So if you can go to the next slide, Dean. We start with something called the Purdue Model. It's been around for quite a while, and there's actually some debate as to whether the Purdue Model is relevant anymore. It dates back many decades, and itself, the Purdue Model does not speak to security inherently. A lot of pictures have firewalls in them when we talk about the Purdue Model, but that's about the extent of it. The way I look at the Purdue Model is as a way to label the components of our networks, of our industrial control system environments. It's probably more than that, but it's certainly not a security framework. The idea is that if we can classify and categorize all of the assets that we have in an ICS network, then we can start to articulate rules. We can create policy, again, usually at the network layer, because that is where we can have, it's both a focused control, so we don't have to have security controls in many places. We can focus that to those network junction points, but also we don't have to take into consideration, it allows us to have that broad control without having to figure out how to interact with each and every single device. In some cases, we can't run software on those end devices. In some cases we can, but we don't want to because we don't want to impact their operations. So the Purdue Model, really, it allows us to articulate those rules, design and implement or at least speak to the controls that we're going to put in place. If I can put a label on everything, then I can group it into categories, put like assets together, and use that to segment my network, and then put those network-based controls both for controlling the flow of communication and monitoring it in between those segments. So we'll dive into this a little bit more, but you can see what we are most focused on and what attackers are generally most focused on is what we call Purdue Level 3, which is where our site, in the case of a plant, or region, if we're talking more electric or oil and gas, where we have all of the systems that supervise and have the ability to control and affect our entire environment or a wide range of systems. We want to protect that from potentially physical attacks on the plant floor out in the field, as well as the business network. But as much as the Purdue model wants us to, or helps us to separate and segment and control the flow of communication between these different networks, we can't do that universally. We still need some communication between what we would call the business or the IT network and the control system network. And this, just as an example, this relates quite closely to the Colonial Pipeline incident. Many of you are probably familiar in some way with ERP systems, right? SAP, Oracle, JD Edwards, enterprise resource planning, right? They are a critical component for most businesses. That's the end. That's not the engine of the business, because that's what I say ICS systems are, but it is the system that makes the business money, in that it allows the business to track what's going on, take an order in the case of ICS, understand what raw materials are required, potentially what we need to make a product, what we have on hand, and then to communicate back out and track that, hey, I've produced something, I've sent something somewhere, I've sold it to somebody, because ultimately all of our ICS systems are in organizations that are either directly looking after human safety and health, things like water, for example, or are being sold. Electricity is sold, oil and gas is sold, products that we manufacture are all being sold. These companies exist because they're profitable to somebody. So we need to be able to keep track of the fact that we've sold something, shipped something, made something. And so there's that billing component. And what that means is the vast majority of the times with the large companies, whether you're making bread or you're pushing oil down a pipeline, electricity down a wire, the ERP system has to talk to something called a manufacturing execution system. And that might have different names in different industries, but it's a system that is managing the actual work, that is keeping track of what's going on. And that affects the capacity, the operations. Hey, you know, I know this machine is idle, let's go make something. I know that I have ingredients to do this, but not do that. I have capacity to store or ship or whatever. And then eventually we can get that product out the door. And then those systems have to communicate back to the ERP system and say, hey, we just made this much product of these components, it's shipped to these people, go get their money. And for all of those reasons, we have to have those connection points between the IT and the OT networks. So if we move on to look at an example for Colonial specifically, or that we could relate this to the Colonial environment, this isn't just them. We have a manufacturing execution system, and maybe we know that tanks A and C are available or they're full, and we can make a product, a specific product. Does anyone want that product? We need to know that. So maybe at step 3, we're still in the business network, we're going to create a production order. We're going to look at what ingredients we need, the quantities, the recipe, and decide that we need to make a product. Now, at step 4 and 5, we need to actually send that order, if you will, over to the manufacturing side, and then get acknowledgement that that order has been received. That could be air-gapped. You could have someone sitting in a chair, taking an order, turning around, you know, like at your typical fast food restaurant, right? Print out the little thing, put it on the spinny wheel, spin that back. The cooks can pull the order down and make the meal. But that's not really efficient. That takes time, takes more people. It's prone to error. So quite often this is an automated process. We are sending this order into the ICS network and getting confirmation back. Then at step 6, we're looking at getting the resources together to make the product. And then at step 7, we're going to automate and actually, typically it's automated, manufacture that product. Now, step 6 and 7, those can happen regardless of our connectivity to any external networks. So we can see that in some of the incidents we've seen, the incidents that affect industrial companies, they'll say, well, our production wasn't affected. That was all IT systems. Don't worry about that. No personal information was stolen. But they were able to keep producing whatever it is they're producing. That's what's happening here. This is why. But you also need to let the business systems know that you're done, so that, again, we can deal with billing and tracking and shipping and all of those things. So that's what's happening at step 8, back across that boundary. And then at step 9, we could hold on to product, especially if we don't have that connectivity to do something with it, and wait for the business to tell us what to do about it. So there are lots of points of communication between IT and OT. We can't, as much as we would like to, we can't fully segregate IT from OT, which means we have to have some level of control over how they communicate. So if we look at the, next slide, Dean, if we look at the Colonial incident, we had something very, well, they had, not we, something very, very common happen, of course. They had ransomware in the IT environment. For all intents and purposes, that was what actually happened was 2 things. Their management execution system, their billing system was impacted by the ransomware. It wasn't there. It wasn't available. So all of a sudden they couldn't take orders. They couldn't invoice in particular. They couldn't bill. They couldn't track who was taking product out of the pipeline. And that's not a profitable way to run a company. You could, that has major, major consequences for an organization. So take that combined with the fact that they were guessing, didn't really feel confident that the ransomware wasn't going to spread into the OT network. So they segmented that network. They had ransomware on that management system, and they segmented their network, or they removed those connection points or blocked those connection points to make sure that ransomware couldn't spread further and cause more damage. That's what caused them realistically to go down, if you will, and be unavailable, unable to ship product for give or take a week. And that was, as we all know, significantly impacting. Before we talk about what they could do about this, I just want to touch on a few more architectural, well, I'll fold it into this discussion. In ICS 410, we have what we call the ICS 410 reference model. Now, this is based on the Purdue model, but it's been adapted or enhanced to really speak to the security of the environment. So you'll see in this diagram or in this model, we have multiple components. At the very top, we have our internet and we have our enterprise networks. We're not too worried about that in this discussion. Wherever you see major enforcement boundary on here, that's a firewall, generally speaking anyways. So obviously you're familiar with the ones on the internet side of enterprise networks, most people are, but we want to have that same kind of protection between the IT networks and the ICS networks. For all intents and purposes, the business network is to the ICS network what the internet is to the business network, right? It's untrusted, it's less trusted. Within the ICS network, we break it up into multiple levels, and these are the Purdue levels. So level 3 is where we have our supervisory systems, and you can see multiple instances of this. We might have control centers. We might have data centers, those 3 boxes across the top. We might, though, have some site-wide supervisory systems down in the bottom left there in a large site or at a plant. And then we also have level 2, where we have some of the similar supervisory systems, but with a smaller span of control, local to a process. And then, of course, getting down to the controllers and the process itself. And we may have many, many instances of these. So we have our supervisory systems. They're typically Windows. They're typically commodity network protocols, commodity operating systems. We understand them a bit better. But then as we get down to the process, we may have many, many instances of these specialized systems, often across a wide area network. Now, it's difficult for us to apply security at the endpoint because it's different technologies, different vendors. In many cases, there aren't security tools. So we have to begin with the network, and that begins at the DMZ. We have, as I just described, lots of communication paths or requirements back and forth between the IT and the OT network. We don't want a free-for-all though. We want that major enforcement boundary to control that communication and to restrict what can go back and forth. To do that, we need the network segmentation. We're grouping systems based on the Purdue Model, as I said, and creating those DMZs to mediate traffic and those enforcement boundaries to help with that. That allows us to, number one, basically enforce the concept of least privilege, right? You can only talk to the things that you're supposed to be able to talk to. If there is a compromise, we can contain that with a little work and a little luck. And we got to keep in mind that we're not just segmenting different levels, but we can segment within a level. You have different vendors working in your environment. You have different kinds of systems. So we can also create some enforcement boundaries within a single level to control what's going on. We need that level of control and visibility, and that's what these models help us do. They help us articulate what we need to do to create that segmentation and control that flow of communication. Those are our two key goals. And the last point here is our attack surface, right? Attacks can come anywhere, or from anywhere, but most often, as Dean described, we see attacks coming into the business network, looking around in the business network, finding out about the industrial control system network, then getting through that enforcement boundary, through that firewall, if one exists, landing at level 3, and where there are commodity operating systems, there are protocols that attackers are very familiar with. And sometimes, like we saw with Ukraine, that's all they need. They can take control of those systems. They don't need to understand the process. They have an HMI with a button that allows them to dump water or dump lye into the water or increase the levels of lye, to close breakers, to do whatever. So we need to have those enforcement boundaries between IT and OT, and then often within level 3 and between level 2 and 3 to further segment our communication. So I could go on, but we'll move on to remote access here, I think is coming up on the next slide. Do you want to just oh no, I forgot about this one. So I talked about this already. My point here is, again, the IT-OT boundary is where ICS security begins. If you have nothing today, if you're starting out with an ICS security program, that is where you need to begin. When we do assessments, that's where we begin. Control that communication between the IT networks and the OT networks. That may include cloud access, that may include remote access, internet access in some cases, ideally not. So we may have multiple DMZs to do this. And as I mentioned, we want to segment level 3, especially. There's further segmentation because we have different groups of systems at level 3. And then we have the enforcement boundary below between 3 and 2 and so on. So this is where attackers land. They have sensitive data. They have access to broad span of control, and sometimes that's all they need. So one last, on the next slide here, discussion is about remote access. I won't spend a ton of time on this, but we have a lot of vendors. They support our systems, they maintain our systems. Sometimes the contracts require that to happen, and they need remote access. This is something we do wrong, as we saw with Oldsmar. A lot of organizations have challenges with remote access. So we need to start by terminating all remote access in a DMZ of some sort. So someone connects an external laptop, they land on some sort of firewall or VPN appliance in a DMZ. That appliance then, at step 2, is going to authenticate against some local credentials, a local dedicated authentication mechanism that, as we all know, should include multi-factor authentication, right? You need, that should not be business passwords or business accounts, but it should be dedicated authentication with multi-factor involved. But that isn't all it takes. What we recommend is, as a next step, for step number 3, you are going to get access to a jump server. Think of a Citrix server, a terminal server. I mean, Citrix in ICS, that's a lot of overhead, but some sort of server that you can log into that has specific access. You might have multiple ones for different vendors, right? Vendor 1 versus vendor 2. And that jump server only gives people access to the applications they need and to the networks that they need. And you might have some sort of secure file transfer mechanism, which is number 4 on this diagram as well, whereby you can upload a file, it gets scanned, it gets synchronized into the OT network, and then you can pick it up there. And I kind of skipped ahead a little bit, but when you connect to those jump servers, which is step 5 and 6, you are authenticating against an ICS Active Directory. So again, another set of credentials, ideally, that are ICS specific, that grant you access to the jump servers and only the applications and network access you require. And finally, from those jump servers, you can then access your controllers, your local systems and field devices and so on. It's a high-level view, but it is probably one of the most important pieces of enforcement, if you will, in an OT network. As we saw with Oldsmar, as we saw in the Ukraine, and many other cases, we have to put a lot of thought and care into how we design a remote access. Moving on. Go to the next slide. Just some key practices to keep in mind when we're talking about architecture in an OT network. You don't want internet below level 4. Have dedicated business computers for all that stuff that are not connected to the OT network. We want those strong enforcement boundaries, as I've discussed, MFA, separate authentication, secure file transfer, blocking all communication by default between all of the zones, even within level 3, between different segments of level 3. Permit only what we need, and that gives us a great opportunity to monitor and log all communication. And we'll talk about that as we go through future webcasts, but that visibility comes hand in hand with those enforcement points. I'm a big fan of Active Directory at level 3. It allows us to push security policy and manage security on those Windows systems, but of course it has to be completely independent of the business. And the same thing goes for antivirus and patching and so on. We can manage all of that in similar ways, but we want that separate from the business network. That's just a really quick overview from an architecture perspective. We could talk all day, but it all begins with having that model, that labeling, that categorization, so that we can apply all these other security controls and prevent what happened to Honda and Oldsmar and Colonial and so on. We've got 3 takeaways for you to take away from this webcast. And these are fairly basic, and this is part 1. We will have takeaways coming up from all of these webcasts. But first, I'm going to let Dean kind of situate us here in the sliding scale.
Absolutely excellent, Stephen. Thank you so much. So as Stephen pointed out in his slides, it's really a lot about architecture, and it doesn't necessarily mean $2 and $3 and $4 and $500,000, $1 million. In a lot of cases, there's some hardware to begin with that's already in your industrial control environment to start that segmentation based on the ICS 410 reference architecture and or the Purdue model to kind of up the ante and the security there to do defense there and do those enforcement boundaries. Now, one of the things we're going to take away in a moment is as you do those enforcement boundaries and as you progressively go through your architecture, you're naturally creating points of contacts in the network to do containment for incident response, which we'll talk about in a future webcast, but also for detection. You'll have the ability to do network security monitoring there, which we will also cover in a future webcast in this series as well. So if we're looking at the sliding scale of cybersecurity, what is going to get you the best bang for your buck? Starting with architecture, you're in. It's going to be something that is affordable and effective right out of the gate. And a lot of times, again, you have probably a lot of hardware in place today to help you with that. So sliding scale and architecture is really a good place to start. And what we see, at least the basic of what industrial control system and organization should have today. And we're going to push you guys as much as we can to do detection across passive defenses, and then eventually get to active defense as well in a future webcast as well. So this is how we're going to progress through the series. So I'll pass it back over to Stephen for the top 3 takeaways for today. And we do have a couple elements to talk about after that as well, specifically that free resource we talked about, and a little bit on the upcoming ICS 418 course. So back to Stephen for the takeaways here.
Thanks, Dean. So these are obviously relatively high-level takeaways, but you could spend a lot of time on each of these, mapping out your organization, how all these pieces fit together, and where you can best start, because we can't do everything. We need to start with where we can get the greatest value for the effort that we're putting in for security. And that begins with understanding what is different between IT and ICS security. Among those differences are the different components. We have so many different kinds of technology in ICS. We need to figure out how to group them, how to separate them, how to control how they communicate, where that security may fit, and adapting our security models to ICS. We care about our data, we care about integrity and so on, but safety is number one. It's of people and of the environment. And of course, keeping the spice flowing, keeping the whatever that product is that you're making going. That comes after the safety and the environment. And that is different. In a lot of these cases, that availability is key, right? We can't suffer any major outages. We can't be lacking for that product, the water, the electricity, the power, whatever. So we have to adapt our security model to understand that and not just do security at all costs. We've got to secure our physical world. That's what we're really looking at. And so takeaway number 2 is label everything. Start with the architecture. That's where we have access to do things without directly touching or modifying or having to take down or change our industrial control systems themselves. So label your assets. It's so much easier to then apply security on top of that. And the first 2 things we want to do: segment our networks and control the communication between those segments. Enforcement boundaries are how we do that, and then that also allows us to monitor as well. Start with that ITOT boundary. Most attackers are coming from either the internet and or the IT network or remote access, then work your way down, but focus on that boundary. That's where you're going to get the most immediate value. And of course, understand those interdependencies, right? How do the 2 environments depend on each other? What would happen if you had to segment them, if you had to turn off those connections? How would you do that? What impact would that have on production? How long can you operate in that way, and so on? So those are very high level takeaways, but if you start digging into each one, you'll find that there is a lot that you can do and a lot of work there to keep you busy as you get going on security in ICS.
Excellent, Stephen. So you raised a really good point there. It's going to keep us busy to do defense. And what I want to say is the ICS defense is absolutely doable. And one of the questions we usually get around IT, OT convergence and all that, how do we do more security in ICS? Can we leverage IT? Of course you can. The idea here is to kind of like converge and just find a way to do defense that involves all of the skill sets around you at your disposal. And so little Bobby comic pops up here again, and he gets the question, right? Like, how do I get IT security to focus on industrial control system security and obviously safety, right? And really it comes down to showing the consequences from a physical and safety perspective to the IT security folks. Now, I won't linger on this, but every time I hire someone and get them into the industrial control system security space from IT, they come in, they're pumped to be there, they're excited, it's like awesome, I'm in a plant, this is great, and they want to deploy a lot of IT security tools. So the first thing I do is I actually get them to the plant floor and have those discussions, and again, show those consequences of the risks and impacts in the industrial control space. And very quickly, they're able to understand that the security is not the utmost here, it's safety. How does security support safety in ICS? And so back to the little Bobby comic here, it's IT security control security controls are not always bad, but they have different value. So it's a nuanced discussion to take those IT security controls and put them on the ICS environment as well. How can you do that transition from IT security to ICS? Someone from OT or ICS security can actually have someone from IT to kind of come and job shadow. I've seen that several times where teams can kind of share resources and job shadow each other and get IT folks into the plant. That will absolutely be a good starting point. We do have this free resource just as we close off the session for today with a few Q&As in a moment. We have this free resource for you. It is the poster, which is ICS 410 network model, the reference model we talked about. So it really walks you through that SCADA reference architecture of the Purdue model and how we've adapted it for additional security, which is the basics of what most organizations from an ICS perspective should have in place today. And also this poster walks you through some of the top points and threats and vectors we've been seeing, how the adversary can target your environment. So using this, you can start sort of an assessment. So the next free resource we'll talk about in the next webcast is going to be around assessments for ICS as well. And just before we get to the Q&A, one last slide here really talks about the upcoming course, which is ICS 418. This is really being designed for those managers asked to step over from IT security management that must stand up an industrial control system security program, take on the ICS OT security program and responsibilities, and also for practitioners moving up or stepping up to the management level that takes on those responsibilities as well. So folks could be coming from IT, from ICS, from an engineering background in the industrial control system space, stepping up to take on that ICS security management position as well, or being in place, a manager already in the industrial control system space, taking on those roles as well. So without further ado, we'll pivot to say thank you very much for hanging out with us today. This is the time for Q&A, so we'll go through any questions that you guys have today for the remainder of the episode today, and I'll pass it back over to Carol there for that.
All right, thanks so much. I'll just jump right in since we just have a couple of minutes here. This first one says, with digital transformation so prevalent, how do we ensure that ICS systems are secure enough to transform with the enterprise systems, for example, moving onto the cloud or edge computing?
That's a very good question and a broad question as well. Before I pass it over to Stephen, just a couple comments. What I do see is more clouds being utilized in the industrial control space for monitoring of certain aspects of the control system. I see virtualization being utilized inside the ICS specifically, not shared with virtualization for IT, for things like monitoring and even programs to change the industrial control environment. But back to cloud, I don't see a lot of cloud infrastructure used to control the industrial control environment. There are some ramifications to that, and of course you can wrap security around cloud, but inherently when it goes outside of your boundary and your perimeter, there's risks associated with that. So great question. I will pass it over to Stephen if he has any comments on that question as well.
Yeah, I agree with Dean. There's limited control from cloud, and you would definitely want to think twice about that. But cloud does give you the power. Cloud is the home of all of those buzzwords like artificial intelligence and machine learning and so on, which does give you great power over the data that you can generate, because we live in a data world and a lot of that data comes from our industrial environments. What we're seeing, and we're actually working on updates to the reference model that incorporates cloud. So absolutely, you will see a cloud DMZ in that reference model today. And again, it gets a little bit more complicated for sure, which is why we're still working on how to fit that in. But I like to think of having an additional level in the Purdue model that's almost a vertical level down the side. And that's where we put our cloud systems or systems that need to talk to the cloud, still having that communication mediated by something in a cloud-specific DMZ. And so then any devices that have any of that external communication paths, we still put them, they're in our ICS networks, but in a separate zone where we at least have some sort of control over how they're talking back and forth. But I think this is going to continue to evolve and change drastically over the next few years, and we'll have to see where we end up.
Absolutely.
All right, thanks. This next one says, what do you suggest, separate OT SOC or a hybrid IT OT SOC?
It's a good question. I'll brief this one. I'll pass it over to Stephen as well. From my experience, having a converged security operations center does a lot of great things. Political things aside, you know, IT fighting OT or vice versa, if you have visibility as a security engineer or operations analyst, you have visibility over IT and ICS. The obvious benefit is you see the adversary potentially targeting IT and traversing towards ICS and then activating their attacks inside the ICS as well. So it gives you visibility, hands down. It's the best approach for security visibility. There are challenges with that. So it's really all about starting, I would suggest in general, starting with an OT, IT converged SOC. It's all about starting with those conversations with IT though, making sure that they're trained up to understand what ICS really is, what it looks like, how to do security, which is different than an IT. So I'll pass it over to Stephen on that one.
Yeah, I'd agree almost completely with that. Just a few other things, you know, for me personally, if I'm working in a SOC or doing monitoring or defense, blue teaming, I want that as much visibility as I can get. I want to see that attacker all the way through. One of the interesting things that is starting to come up now is SOAR, right? What do we do on the response side? And I think that's where we need to have a bit more nuanced discussion, because we have to be a little bit careful about those automated response actions when we get into the OT environment. So political stuff aside, honestly, is there really data in your OT network that you don't want your IT security analysts to see? They see everything else. I'm not too cut off on that. We can use DMZs to get data across. So I want that full visibility. It's really when we start to get to the response actions, we have to be a little bit more careful.
Agreed.
All right, well, that's all the time we have for today. Thank you so much, Dean and Stephen, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.
Thanks, everybody.
Thank you.